We are on the way of solving our. So let's continue. And yeah, let's check our roadmap. So we have binary search, and the next one is search in 2D matrix. So what do we have here? So we are given a matrix and with the following two properties. Each row is sorted. So we have each row, and the first integer of each row is greater than the last integer of previous row. Given an integer target, return true if target is in matrix or false otherwise. You must write solution in log m n. Okay, so in this case, first it would be find row, right? So by finding row, we have left 0 and right. So we have different types of matrix, 3, 4. So here we have 0, and right, it would be number of rows. So it actually matrix length. Then while r minus l is greater than 1, we are calculating our mean. So it will be r minus l divided by 2 minus plus l. And here we will check if matrix. So here we have row m, and we need so we need a row 0. So we check 0 column. So if it's equal to target, then we return true. Otherwise, we can just check if it's less than target and else. So if target is greater, then we should we are going out of charge, but let's continue. So we have some value, for example 10, but we are looking for 12. So if tell 10 target 10 is less, and we should move our left pointer. So left becomes m, and here r becomes m. So in this case, and here row minus 1. Yep. So in this case, we can say that row is equal to so can we say that it's always equal to L in our case? Can we say that? So I think if we will take here 0, then I believe we can say that is equal to L. And now we need to find a column. And we start with 0. And also L equal to 0, R equal to matrix. Here we take 0, row and length. while r minus l is greater than 1, we actually try to find mid, so the same logic as we have here. But here we already found a row, and here we have row, here m, row, and m. Yeah. So the same logic, and at the end we just return false here. Here we return true. So let's run this. Okay. And let's submit. Okay. What if equal now what if we will start with -1 here to use this use case? Yeah, and here what we can do, we can check if L is equal to -1, then it would be R, otherwise L. Yep, and we finalize with beating 100%. Let's check previous implementations. Yes, so the same, actually the same logic. The same logic as we implemented. Here also the same. Yeah, this one is more complex. But we finalize with this task. Let's implement the next task. Okay, so we have Coco who loves to eat bananas, and there is n piles of bananas. The ith pile has piles I bananas. The guard have gone and will come back in 8 hours. So we have piles of bananas, and we have hours when guard will came. So what we need to find, so we need to return the minimal integer k such that she can eat all the bananas within 8 hours. So what we can do, we can take some max value. It would be integer max value. And then what we want to do, we want to find the minimum of the speed. So we want to find the minimum speed here. So it would be the maximum at minimum minimum speed, it would be 1. And here what we need to do, like while max minus minimum, is greater than 1, we need to find a middle. So the same like max minus minimum divided by 2 plus minimum. And then we have to calculate the speed. So to calculate the current M and then piles. And after we calculate the speed, we need to check if our speed is greater than h. So it means that we spend more hours than it's required. So for example, then we should update min, else max update to m if it's less. And also in case of equality, we should run, move our maximum. And at the end, I think we just need to return our minimum speed. So let's calculate our calc speed. So for calc speed, we need speed and piles. So what we have here, we have our result. Then we just go through each piles, and here we need to add into our result like in which how many time do we need to eat all piles. So for example, you have so if we have, for example, 3 piles, so we can divide a pile by speed plus if pile mod speed greater than 1, then 1, otherwise 0. So we need to also do like this, and then we return result, and we can check. Mm-hmm. 3 here, 28, 21, and what if we will return maximum? Okay, and like this. Five. Yeah. Here we go. So if speed is greater, then I think we should move max to middle. So if our current speed that we calculate is greater than h, Okay, so let's calculate this. So for example, here we have output 3, but if we have 3, then here we have 1 plus 2, 3 plus 3. Now we have 2 plus 3, 5, 6, and here we have more. So maybe at the end we need to check our speed. So we have calc speed minimum with files. If it's equal to h, we return minimum, otherwise we return maximum. Okay, let's check what we have here. Okay, so we have the same idea with speed. We start with 0. Okay, so maybe you can start with 0. Yeah, we can start with 0. R minus L is greater than 1. Here we calculate if speed is greater than h minimum maximum, and then we okay, and we return always maximum. So maybe the problem is with this max speed. Maybe let's check and just take this value. Yeah, but I think here is some problem we have. So max minus min. So I think here it can be the problem. I'm not sure. Yeah, I'm not sure. So max minus greater, calc speed greater, also greater. Maybe here we have some problems. Pile divided by speed. Yes, speed. And I greater than 1. Maybe here greater than 0. Yeah, so here's the problem. Right, but we have wrong answer. We have wrong answer here. Output 1, expected 3. Why? Okay, so I think that probably was long. So we still need here the long with calculation. Yeah, and here we should like to add files in them. Yeah, so the problem was with long, and we solved this problem. Yeah, that's all for today, and see you tomorrow.